Magnitude 2 and smaller earthquakes occur several hundred times a day worldwide. Major earthquakes greater than magnitude 7 happen more than once per month. Great earthquakes, magnitude 8 and higher, occur about once a year. In this video, students will be able to gain information about earthquakes and seismic waves, understand the different types of waves, and know how scientists measure and can predict where an earthquake may occur. An earthquake is defined as the shaking of the earth caused by sudden motions along fractures in the earth's crust called faults. Seismic waves are defined as waves that transmit the energy released by an earthquake. October 17, 1989, at 5:04 p.m., San Francisco was struck. The San Andreas Fault, the Pacific Plate and North American Plate, ruptured due to a massive amount of strain energy. It released the seismic waves, thus the Loma Prieta earthquake was created. Buildings crashed and hundreds died in this tragic accident. There are three different types of waves: P waves, S waves, and surface waves. The first set of waves is P waves. Primary waves are the fastest. They can travel up to 3 to 5 kilometers per second, similar to a sonic boom. They usually cause very little damage. They're comprehensional or longitudinal waves to push and pull the ground in the direction that the wave is traveling. They pass through the Earth's liquid outer core. Secondary waves, known as S waves, come next. S waves travel more slowly than P waves, up to 2 to 3 kilometers per second, although they do cause greater shaking. S waves are more dangerous than P waves because they have greater amplitude and produce vertical and horizontal motion on the ground surface. S waves travel in the same direction and shake the ground back and forth perpendicular to the direction the wave is traveling. After the P and S waves, surface waves come into action. The slowest of the waves. They can turn roads into rubble. These can be the most destructive waves as they roll along, lifting and dropping the ground as they pass. Level waves move back and forth horizontally. Rayleigh waves cause both vertical and horizontal ground motion. Seismometers are instruments that measure motion on the ground, including seismic waves generated by earthquakes. Because we know the velocity difference between the P and S waves, we can use it to determine how far the earthquake is from the seismometer because it shows up as a time lag between the rev of the P wave and the S wave on the recording. If we have several seismometers, we can use it to triangulate the position of the earthquake so we can determine its location. S minus P time recorded at the station and multiplied by 8 kilometers gives you the distance from that station to an earthquake location. Scientists can know where they are to be occurred, but cannot predict them.